Me?
He like
Cracked it.
crazily.
All right. Okay, so we're going to talk about alternating series today. All right. And we're going to talk about the alternating series test, which tests for convergence or divergence. And I'm going to give you an example of an alternating series. I'm going to tell you how we can tell whether an alternating series converges or diverges. And then we'll actually look at an alternating series or two or three. All right, so we say that we have an alternating series. All right, an alternating series if the signs between the terms alternate. Plus, minus, or minus, plus, minus, plus. Okay, that's an alternating series. Furthermore, we can tell if the alternating series converges or diverges by looking at two very important things. So, this is an alternating series, plus, minus. I want you to look at how we define the series. Can you see what what's controlling the sign, SIGN? Alina, can you see what's controlling the sign of?
Whether the exponent would be odd or even if it was odd.
Exactly. Right? So this -1 raised to the, I wonder if oh boy. That didn't do any good, did it? This -1 raised to the n-1. Now, oh boy. It could be -1 raised to the n, but if it was -1 raised to the n, what would the sign of the first term be? Negative, right? So if it's n or n-1 or n+1, that determines whether you start with a minus or start with a negative. For all intents and purposes, n-1 would be the same as to the n+1, right?
Yeah.
Okay. So this is the guy that's controlling the pluses and minuses. I'm not looking at the pluses or minuses. I'm just looking at the terms, B1, B2, B3, B4. Okay, so this is an alternating series. Furthermore, if these two things hold true, we can tell immediately that the series converges. So in some sense, if you know you have an alternating series and you know these things hold true, it's actually a really easy test. What are the two things that need to hold true? All right, so first thing that needs to hold true is any term has to be less than or equal to the term before it. Okay? So in other words, the terms have to get smaller. And
that's magnitude-wise.
Right, because we're not talking about the signs.
Yeah.
Remember, B sub n just represents the term without the sign, right? The -1 to the n-1 takes care of the sign. And the terms have to get close to 0. And just like as a real, quick aside, like what if the term was 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1?
Easier?
Right? Well,
maybe between 1 and 0.
Right. Because you can decide, hey, I want to group these like this, which would be what? Like 0 plus 0. Or I want to group these like, whoops.
You do it by 3s.
I want to group it like this.
Oh no, that would still be 0.
No, sorry. Nope. Hold on.
Yeah, you'd have to include the first one.
Hold on.
I think these don't have to not include 0.
It's just not listening.
Yeah. Plus 1, minus 1, plus 1. All right. So if I wanted to group it like, hey, 1 minus 1, right? Minus 1 minus 1. Do you see how that's another way of grouping it if you distribute the minus sign? So that's 1 minus 0 minus 0. 1 minus 0 is 1, right? So the problem with this one is it just goes back and forth between 1 and 0. So it doesn't converge. It doesn't get close to something in the long run. So that's why it's important that the terms eventually have to get close to 0.
Could you write that as like a sine function if you chose to?
Yeah, you're saying like, could I define it differently? Yeah, you can, right? So you're doing like sine of pi over 2 plus n pi, I think off the top of my head. All right, so this is an alternating series. If the alternating series does two very important things, the terms get smaller in magnitude, as Greg said, and the terms get close to 0 in the long run, we know immediately it's convergent. You ready for an example, or you want to ask a question? You could do both. All right, let's do an example. So here's a very famous example. All right. Is it alternating? Say yes. Yeah. It is alternating. Is each term less than the one before it?
Yes.
Or are the terms getting close to 0 in the long run?
No.
Yes, they are.
Because eventually it is going to reach 0.
100th minus 1 over 101
Yeah, but if you start with
plus
1.
No, each
are the
term.
terms. Like
Oh,
the
yeah,
terms,
yeah,
right?
I'm sorry.
Terms are getting closer and closer to 0. So that's all we need to know. By the alternating series test, this series converges. All you need to know is recognize it. All you need to be able to do is recognize this in an alternating series. So look for the plus minus plus minus. Make sure that each term is less than the one before it, and make sure that the terms, not the series, but the terms get close to 0 in the long run. Those things tell you it converges, and that was easy. Now, it doesn't tell you what it converges to. It tells you it converges, but doesn't tell you what it converges to. More on that in just a second. I'm going to give you a small informal proof, but how'd that example go? Greg?
I was just going to say, would something like that, would it eventually be to 0.75?
Yeah, interesting, right? So Greg wants to know, what are we getting close to? We'll talk about that in a little bit. So I'm going to actually use that as we'll start on talking about it a little bit, but just I want to remind you that oftentimes, even though we can tell whether a series is converging, oftentimes we can't tell what it's converging to. If it's a geometric series, we are absolutely excited because we have a formula for finding out what the sum of an infinite geometric series is, but we don't generally for other types of series. Frustrating.
What is the geometric one again? Is it a over n minus 1 or something?
So so
a over 1 minus r. Yeah.
and that works great if it's geometric. I actually wanted you to ask me a question, and I forgot that I wanted you to ask me a question.
If you whisper to me, I'll ask it out loud.
I wanted you to ask
So
me
the recording can get it.
a question. Whoop, nope. Go back. I wanted you to ask me a question about these two restrictions, or these two tests. I'll tell you what I wanted you to say, and then you can tell me if I'm just crazy. I wanted you to tell me that they're redundant.
Well, yeah, if the second term is smaller than the one before it, then
Yeah.
it's clear when getting towards
Well,
it.
not necessarily,
Why
you
is that not necessarily?
because it is necessarily.
Are you sure?
Well,
Isn't it?
you can get small without reaching 0, can't you? You can get infinitely small without reaching 0.
You get close to 0 though.
Well, yeah, if you
I
always,
understand
always go
what you're
halfway.
I agree with
Okay.
David because there can be like asymptotes, like if you think of that,
Alright.
there can always be like approaching affinity zeros like after a decimal point before a number being
Like,
added.
let's say
But
he's
you're
trying to walk to the
approach
wall,
and then but it doesn't
and
actually
you can only go halfway.
like
He's never gonna get there.
So I want to clarify, like, there's a
approaching the
limit.
wall.
Yeah, but
So,
he's not gonna get
A limit
Approaching it, that's what it is.
a limit means something that we're getting close to. I do want to pick up a little bit on what Alina said about like these asymptotes. Is it possible to have numbers that are smaller and smaller, that are smaller than the one before it, that aren't getting close to zero? Like, is it possible to have other asymptotes?
Yeah, but it's gonna get close to something.
Going to get close to something.
So not
Alright.
zero.
So can I give you like an example? What if we had like,
But doesn't it already say up at the top that B sub n is it's already there?
if we had like, let me think, 2 over 1 minus 3 over 2 plus 4 over 3 minus 5 over 4 alternating,
Yes.
okay, is each term less than the one before it? Are the terms getting close to 0?
I don't think
No.
What are the
They'll
terms
never-
actually getting close to in the long run?
so.
1. So we're going to end up in the long run adding 1, subtracting 1, adding 1, subtracting 1. That doesn't converge. That bounces back and forth between two terms. So we can have values that are less than the value before it, but that don't go to 0. And if it doesn't, then we can use the nth term test, right? The nth term test says, hey, if this doesn't get close to 0 in the long run, it's got to diverge. And this doesn't get close to, the terms don't get close to 0.
That's true for all series.
That is, the nth term test is true for all series. All right, and that's, I want you to think about that too. Just because we learn new tests doesn't mean our old tests don't necessarily work, right? So it's helpful to know that. What about this? If this is true, do we need the first one? If the terms get closer and closer to 0, do I need? Well,
In fact, you could have a geometric series that was
Well,
also
couldn't it-
alternating.
No, because you could approach it from the negative side, couldn't you?
well, we're gonna alternate,
It'd
right?
still be getting.
Yeah. But if you have like the first term, like
So it could be negative. That's fine. So I'm saying like, remember, and I do want to be clear. Remember, when we're talking about b sub n and b sub n plus 1, we're talking
you're
about
right, 'cause I was thinking
these terms, not the pluses or minuses. So if I say this, is that enough? Like,
Well,
clearly not.
that would
Alright.
imply. Oh,
But
wait. Would that be implying that they can't be equal?
how would you have them be?
Well,
Uh,
because the other one says that the next term can be equal to or less than. And I assume that you would. I don't know. I mean, I guess you could. Like if you had a slope of 0, like the limit could be, the same as you went past.
so I think actually as we look at this, if we remember, if they're equal to each other, we're still out of luck unless they go to 0 in the long run, right? Because if each of these terms was 1, or even a half minus a half plus a half minus a half, so if they're equal to each other, that actually doesn't do me any good unless they keep getting closer to 0.
I'm just thinking of like
So-
a negative x cubed function where it does that. Like it flattens out for a bit and then keeps going. I just mean like as you keep
Yeah.
going, there will be a point in time where some of the points are the same at different limits than as they will be later on.
I really
So,
feel
like,
like
that
the
would-
first one, if you look at the second one first, then the first one isn't necessary. But I know that's not true because they have it there. I just can't,
Yeah,
can't
so-
wrap my head around anything that says otherwise.
And it took me a while. Like I actually did a lot of looking. So I tried to find something where 2 is true, right? 1 wasn't true, and this didn't work. So you really do need 1 and 2, and I'll show you the one that I found, and I didn't come up with it, but I found it. This one we already looked at. That's actually the one we just looked at. This was when we plug 1 in, we get 2 over 1. When we plug 2 in, we get, we get 3 over 2, except that should be a minus. Plus 4 over 3 minus 5 over 4. That's the one we just looked at. This is the one that I found. So I have 2 over 1 minus 1 over 1, plus 2 over 2 minus 1 over 2, plus 2 over 3 minus 1 over 3, plus 2 over 4 minus 1 over 4. What's the next one over here? Plus
2 over 5 minus 1.
2 over 5 minus 1 over 5. So,
You're essentially just adding.
are the
No.
terms getting close to 0?
No, they're not. They're getting bigger.
No, they're
No, they're getting smaller.
Because
Oh,
if
it's
you
getting
take the
smaller.
two next to each other with the same denominator, then they.
It's getting
Very small.
smaller,
No,
but
they
we're
get
still
smaller
adding.
than bigger
Like, look,
than smaller than bigger.
pair
So
the.
I'm asking.
Wait,
I'm asking. Are the terms getting closer to 0?
Yes, but
Oh.
they're not one. So 1/5 is going to be smaller than 2/6.
Right.
Because
So
you
the
have-
but the problem
Even though
it's definitely true the terms are getting close to 0, right? Somewhere out here I'm going to have 2 over 100 minus 1 over 100. Those are close to 0, right?
But the consecutive integers aren't getting smaller.
But the problem is this isn't smaller than that. And this isn't smaller than that. And that's a problem. Because watch, I think Emily even said it. I'm going to start grouping.
Then you're just gonna have a third.
When I group like this, I have 1 plus a half plus
And we know that diverges.
a third plus a fourth plus a fifth. And Emily says, hey, that's the harmonic series. That diverges. So that's why it actually is very important to have both of these. So not only do the terms have to get smaller, but each term has to be less than or equal to the term before it. Is that okay? All right, ready for a quick, like, informal proof? Say yes.
we believe you. we always believe you.
This one's not bad. Okay, so here's my informal proof about why an alternating series is going to converge. I'm going to start
Well, when a convergent alternate series is going to converge.
why an alternating series that behaves the way we just said
Okay,
it
yeah,
is.
okay.
You're right, I should have said that. Is going to converge. So the first thing I'm going to do, I'm going to take my first term, and in this case, I'm going to have that be a positive term. I'm going to start off positive, so I'm going to add it, and that lands me right here at B1. The next thing I'm going to do is subtract my next term. Now, what has to be true about my next term?
Less than the first
Smaller.
term.
It has to be less than the first
B2.
term. So I'm going to land somewhere here, but I know it's not going to be on the other side of 0, right? So that's going to be B2. Now I'm going to add the next term.
B3.
And I know that it's going to be less than B2, right? So I don't make it past B1, right?
Yep.
It's going to be somewhere here.
Less again.
And can you see how
Yeah.
as these get smaller and smaller and smaller, I have to get closer to something,
And there,
right?
that infinite term is 0, right there.
Say,
The
so
infinite term is 0.
the terms, right? Exactly. The terms are getting close to 0, so I'm taking smaller and smaller steps. So this idea that I'm going back and forth, I'm never going beyond the one that I just had, and my steps are getting smaller and smaller. Are you convinced that it's going to have to converge? I don't know what to, but it's going to have to converge. Is that okay? All right, I'm going to pause there. Questions, comments, concerns? All right, I'm going to talk about something that I've never talked about before. Happened about 2 years ago. No, I'm just kidding. So I am going to talk about something I haven't talked about before. I'm going to talk about the error. All right. So we've never talked about how far off our approximations are, and what we did was we said, hey, with the integral test, if it converges, the series converges, and they don't converge to the same thing. But wouldn't it be nice to know? Yeah, but you're off by, a tenth, or 100th, or 1,000th, right? If you're an engineer, you're very curious about that. What's the most I could be wrong by? And there comes a point where if you're only wrong by a certain amount, you don't care anymore. You're just like, great, I can use that. I can use this approximation because I'm close enough. So what do we mean? All right, well, let's say we have that series. This series has a very special name. It's called the alternating harmonic series. Is that okay? Because the harmonic series looks like 1 plus a half plus a third plus a quarter. This is 1 minus a half plus a third minus a fourth plus a fifth So this converges, and it would be nice to know what does it converge to. I don't know. But I'll tell you this. If you use the first term, that's what S of 1 means, the sum of the first terms.
Sum of the first terms. The sum of term 1 and term 2.
Nope, the sum of the first term.
How can you have a sum of one thing?
It's just that thing.
It's that thing, right?
Okay.
Okay. If I said, hey, what's the sum of the first two terms? That's better, right? Better English. Half. What if I said, what's the sum of the first three terms? Now you have to do a little fraction stuff.
5/6.
What's the third?
So 5/6.
Whatever that is.
And this is the last one, I promise. I want to make you do. So I need to do 5/6, and now I need to subtract a fourth. So what are we talking? 12ths? 7 twelfths?
It's always gonna be 1.5.
Okay, so let's say you just wanted to use the first term to approximate this sum as 1. Well, here's what I'm going to say. If you just used 1, that'd be a pretty bad approximation of what this thing's equal to. But I would say that the most that you're going to be off by if you use 1, the most you'd be off by is a half.
That's fair.
Because I know that the next term, when I add it, gets me to this B2, and I know that the real answer lies somewhere between these two. So the most I could be off by is a half. I'm going to use that same argument. If I used S of 2 to approximate, if I said, hey, if I add all this up, I'm going to get a half. That'd be like still a pretty mediocre approximation. But the most I could be off by,
It's 5/6.
not 5/6, because that's the sum of the three terms.
A third.
The most I'd be off by is a third.
2/6.
Well, if I land here at a half, I know that the real answer lies somewhere between a half and a half plus a third.
Oh, so you could be off by a third.
Yeah, the most you could be off by is a third.
Or you could be off by less than a third.
Right.
But you couldn't be off by a half.
Right, you couldn't.
Okay.
And if I used the next, if I used the most I could be off by is a fourth. And so here's the thing. With an alternating series, your error is at most the next term.
Nice.
So if I use the first 1, 2, 3, 4 terms, the most I could be wrong by is the fifth term.
Yeah.
And that's actually pretty easy. I'm not saying like conceptually this is a piece of cake. I'm just saying if you understand that, that's pretty easy because you can now tell what your error is. So if someone says, hey, I want you to give me an answer that's accurate to within 1/10. Okay, great. 6th plus a 7th plus an 8th plus a 9th. Well, sorry, I'm not alternating.
Yeah.
Minus plus minus plus minus. So if I use
And that is.
1, 2, 3, whoops. 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. I know that at most I'm going to be off by is a 10th, right?
Although the series might not have a tenth as one of the terms. So if somebody says, I want it to be off by a
well,
tenth, and a tenth isn't one of the terms. then
So,
This one does.
right, this series does, but you're absolutely right. And what that means is all you need to do. So let's take another. Let's get out your classwork. Let's take another example and then ask that same question you just asked. Yeah.
I'm more tired now than I was all break.
Sorry.
Training 6 hours. Are you
Sorry,
I
I'm
have
borrowing
no
it.
idea how jet lagged I am right now. What time is it? It's about 2:15 in the morning for me.
Where were you?
Shanghai.
How was it?
I had a lot of fun. Do you just do sightseeing there, or?
No, I went back to visit friends.
You lived there?
For 3 years.
Chinese?
Some.
Okay.
Mostly European, so they speak English.
Do you agree A and B are actually the same? I can't see any difference between A and B. Like I think it's just a typo. Not here, but A and B on your paper.
Three.
Are they the same?
Which number?
What-
Oh, I don't know. Which?
Oh, here.
Uh,
Oh, 7? Or no, never mind.
Or
11. 11 A and B.
Well, and 7 are the same too.
No, they're not.
12?
11 A and B are indeed
Oh,
exactly
oh.
the same.
Oh, yeah,
11
yeah,
A and B
yeah.
are the same.
Yeah, they're the same.
All right, great. So, let's take a look. Let's take a look at 11 A and B at the same time. So, does this alternate? Does this series alternate?
Yeah.
It does. That's the -1. That's the control guy right there. The -1 to the n and n plus 1 alternates. Is each term less than the term before it? Well, I don't know. Maybe you want to write out the first few terms. Maybe you can see that if I take 8/7 and then I take 9/8, that each term. Oh boy, what just happened there? Do you think? Wow, my elbows.
Ooh, that's the code to everything. Screen capture. Oh, you're recording this. Oh, well. Ooh.
Tell me what it's the code to.
Memorize that and put it on the test.
Yep. Can you tell? Like, are the terms getting smaller?
Yeah. But not zero.
Ah. So Julian says, yeah, you can actually just look at this. This term right here, that's getting closer and closer to 1. Is that going to converge? Come on, say it loud and proud. No. As a matter of fact, by the nth term test, unless the terms go to 0, the series can't possibly converge. Automatically diverges. So that's not a good, I can't ask what the error is on that. Sorry, David. I can ask on this one, though. Does it alternate?
Yep.
Yes.
Does each term get smaller than the one before it? As n gets bigger, do you agree the denominator gets bigger? And so that this number must get smaller? And does it get close to 0?
What is it?
Yep.
Yeah.
It's on the bottom.
Okay. So, automatically alternating series test. This converges. Can you see how easy the alternating series test is?
Yeah.
It's really easy. Now,
Two
the
rules.
problem is this. There aren't a ton of series that alternate. So, it's not like you can use it all the time. But when you can use it, it's simple. I'm ready for your question now. Hey, what if we want to approximate within, what do you want to approximate within? I don't care, whatever you want.
10%.
10%, so 0.1. No, I can't do 10%. Sorry. I need to know a number, like within a tenth, or within a hundredth, or within, 0.005.
Within 1/10.
All right, within a tenth. So here's what I need to know. I need this
To equal 1/10.
to be, I need the term, right, to be, yeah, I guess we're going to say, like, when is it equal to a tenth, right? So when is it true that equals a tenth? Because the deal is this. When this is equal to a tenth, I only need up to the term before it, right? Okay, so what do I have? 2n plus 1 has to be equal to 10, and then I actually have to, like, there's no way to undo a factorial, so I actually have to think about, like, hey, if I took, when I plug in 1,
What is that factorial? It's like 3 factorial is like 1 times 2
That's
times
just
3.
6.
Like,
well, so
how do you
when I plug in 1,
it's
oh, so this,
just-
sorry,
I think it's
oh, this is a margin note.
okay.
All right, margin note. What's the number before 2n plus 1? 2n. What's the number before 2n? 2n minus 1. What's the number before that? 2n minus 2. Whoops, that's a minus 2, sorry. That's just a weird minus sign. Is that okay?
Yeah.
Dot, 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 down to 1. All right. Margin note. All right, back to this. So when n is 1, this is 3 factorial. So what's that? 3 times 2 times 1. Is that equal to 10? Nope. When n is 2, that's what? 5 factorial? 5 5 times 4 times 3 times 2 times 1. Well, that's more than 10, so that means our second term is definitely going to be less than a tenth, which is awesome. So, David, all I need is the first term of this series, and I'm already within a tenth of the actual answer. And I think what I might say would be this. Oh. Let me try that again. So I might say, hey, I want this to be, less than a tenth, which means I need this to be greater than 10. And this does not greater than 10. But as soon as I use my second term, I'm greater than 10, which means my second term is less than a tenth. I just need one term to get within a tenth. All right.
You can use 2 terms, I guess.
You could use 2 terms, but you'll be even better. If you use 2 terms, you'll be within a 20. You'll be within 120th. At most, your error will be 120th. And so I'll leave you with this. Hold on. Let me leave you with this. You use more terms, you're going to be more accurate. All right. Hey, have a great day. Stay out of trouble. You did in time. Nice seeing you back. I'm not saying that. Oh.